So in this case, I'm not going to waste your time as we have done the introduction. So this is part of our exercise. It was exercise 9, and this is a request to work on this question, which was left out on that activity, on that exercise, and that was question number 3, and it was to solve for x. So given this, remember I told you guys, whenever you are working with these rational exponents, all right, where you've got a fraction, try by all means to write one of the given terms in x, which is actually the one that has got the higher exponent or the bigger exponent in terms of the smaller one. So you check what you have is 1 over 3, and there is a 2 over 3. 2 over 3, 1 over 3. Which one is actually bigger between the two? 2 over 3 is bigger. So you are going to write the bigger one in terms of the smaller one, meaning to say, where we have got this smaller one, we're going to write it as x to the exponent of 1 over 3. But remember, I said the bigger one in terms of what? The smaller one. So how can we obtain 2 over 3 from x to the exponent of 1 over 3? How can we obtain? We still want to have the same presentation as before. This is not supposed to change. So you're now asking yourself, which exponent am I going to use? Because already here I've got 1 over 3. So remember, an exponent to an exponent. If I multiply this, that's the number that I need here. Exponent to exponent, they multiply each other. So whatever that you put here, it will be a direct multiplication. So which number are we going to use here to get 2 over 3? So that's a 2. All right. If you multiply 2 times 1 over 3 is what? 2 over 3. Or like I said, if you do not know this, just form an equation. 1 over 3 times a certain number that I do not know. I'm supposed to obtain 2 over 3. What is that number that I'm supposed to use? So simply divide by what? 1 over 3. 1 over 3 here. So this can cancel. So meaning to say our x is going to be a 2. So taking your calculator here, that is 2 over 3. Then divide to what? 1 over 3. So that is 1 over 3 like this. That is going to give us a 2. So as we can see, we are still having that 2. So it is in your hands the way that you're going to find the number that you're going to put here to get. So if you guys, this is 1 over 3 and there is a 2 over 3, just multiply by that. The 2 here, the number that is here. So if it was 4 over 3, you just use the 4 there. All right. 5 over 3, you use the 5 there. That is the condition, all right, which is an easier way for you to actually have. So if it is 3 over 3, which is actually a 1, 3 over 3 means a 1. So you're just going to use that 3 on that other part. So this is what you have. Multiplying this, this exponent to exponent is simply giving us the original term as it was. You haven't changed anything. So meaning to say you're going to rewrite x to the exponent of 1 over 3 raised to the exponent of what? 2, which is this one. Okay. So that is what you're going to have. So this part is now simplified in terms of the smaller one, x to the exponent of 1 over 3, the one that has got the least exponent. So rewrite everything as it is. All right, so that's it. We have formed an equation in the way that is easier for us to solve, which we can solve as it is, or we can introduce the constant k in place of what? X to the exponent of 1 over 3, which is the common, the one that is now common. This is common. We have it. We also have it here. So that is the one that we are going to substitute with k. So let that be represented with what? With k. k be equal to x to the exponent of what? 1 over 3. So simply here, in place of x to the exponent of a third, it is going to be k squared, because this is squared. So k squared minus what? This whole part represented by a k minus 2. That's equal to a 0. From this, you are back to a normal quadratic equation that you are used to. This is a quadratic equation now. It's a quadratic equation. So you can solve that. All right. Solving for x, for k. And before you can solve, also you can interpret what is happening here. X to the exponent of a third is the same as the cube root of what? Of x. Remember, x to the exponent of 1 over n is the nth root of x. So meaning to say the cube root of a certain number here, the cube root, to determine the cube root of a number, it can be of a positive. You can have the cube root of a positive number, like let's say the cube root of what? The cube root of 27. 27 is positive. You can determine its cube root. Let us use a negative here, negative 27. You can also determine the what? The cube root of a negative here. What is the number? This one, the number here, negative 27. It is possible. So meaning to say x to the exponent of 1 over 3, which represents the cube root of x. In our case, it can be that it can be positive, it can be negative, because we can determine it from a positive or from a negative value. So therefore, the answer can be positive or negative. You can have a positive or negative answer there, which is what? From what you're given. So meaning to say, if you are having the value of k as a negative, it is still required. So I'm explaining this so that you can also answer other questions using this same information. If let's say it was x to the exponent of 1 over 4, it means what? The fourth root of what? Of x. Can we determine the fourth root of a negative value? Is that possible? Same as a square root. Is that possible to determine the square root of a number which is negative? All right. Using your calculator, the square root of a negative 4 does not exist. This does not exist. Same as, let's say, the fourth root. All right. Let us use the fourth root of a certain number, which is a negative, negative 16, like this. You cannot determine that. You can determine the fourth root of 16. You can determine the fourth root of a positive 16. You can determine the square root of a positive 4. You can determine that. Not a negative, but a positive, if the number here under the square root is what? Is a positive. You can determine that. So this is what I'm trying to explain. Say, whenever you have this condition, test or check what you have here under the square root. Is it possible for you to have a positive or a negative, so that you are not going to use all the solutions? Sometimes, yes, you can have all the solutions, like in this case, but other, you are limited to only one solution. So use that to answer any other questions that you're going to have. Anyways, like I said, here we've got a new equation to be solved in terms of k. So simply solve for what? For k, which we can use our factorization concept by what? By factorization. So if we are to apply by factorization method, I'm just going to, all right, this one is direct. There's no need for us to use the cheat method, because the coefficient of k squared is what? Is 1. So meaning to say our factorization is just going to be direct. So what we're gonna need here is to get positive 1, we must have k and k here. All right. Looking into the constant, so you focus on the constant, -2. What are the factors? What are the products? These products must add up to a negative. What is that negative? -1. So products, here we need what? Products of -2. -2 and 1, 2 and -1. These are the products, the factors. But of these factors, which pair are we going to consider adding and obtain what? A -1. So this happens here. If you add these two, you're going to get a -1. So this is what we want, -1 and -2 and what? +1. So this is -2 and that's a +1. So from this, each of the brackets must be equal to 0. So determine the value of k. -2 to the other side is going to be a positive, or our k is going to be what? +1 to the other side is going to be a negative. So that's a negative. This is going to change to a positive, change to a negative. So these are the possible values of k, not x. We are to solve for x in this equation, x. So we are going back where we introduced that k. Remember, where we introduced our k here, we said it is what? X to the exponent of a third. So in place of that, let us substitute x to the exponent of what? A third. X to the exponent of 1 over 3 is equal to k, where our k is what? Is 2. Or we are going to have x to the exponent of 1 over 3, which is equal to -1. So that is why I was explaining this here, to say x to the exponent of a third means the cube root of what? Of x. So the cube root of a number, the number that we have under that root sign, the number that we have can be positive, can be negative. So meaning to say the cube root of what? Of x, the number that we're having, is it gonna give us a 2? It can possible, we can have that. And also the answers, we saw that when we have a positive, it will give us what? A negative. Here, sorry, a positive, it's gonna go to a positive, a -2, a negative. So it is possible. So on that condition, guys, do not waste your time. Find the reciprocal of what? The exponent, 1 over 3. What is the reciprocal of 1 over 3? So that is 3, the reciprocal. So in our case, we are going to use what? 1 over 3 as what? As this one as 3. So raised to the exponent of 3 to the exponent of 3 to the exponent of 3 to the exponent of 3. So that's we're going to have the values of what? The values of x from there. So this one is going to give us a 1. 2 to the exponent of 3 is what? Is 8. All right. The same here. We are going to have what? A 1 here. So that's x to the exponent of 1. And -1 to the exponent of 3 is -1. Just use your calculator as well. That is going to give us what? A -1. So these are the possible values of x from our equation. It is possible that the cube root of whatever that we have, we can determine the cube root of a negative. We can determine the cube root of what? A positive value. So both solutions are to be what? Are to be considered. You are to use or to have these solutions on your final answers. All right. So that is how to attempt this. That is how you can simply attempt such a typical question.